The title of today's lesson is Writing and Graphing Inequalities. So we have 2 learning targets for today. Number 1, I can write an inequality to represent a situation. So now we're going to be thinking about real-world situations and writing our inequalities to actually represent them. And 2, I can graph inequalities on a number line. So let's look at our first activity. Estimate heights of people. So here's a picture of a person standing next to a chair. It says, name a number in feet that is clearly too high for this man's height. Okay, so we know like an NBA player, let's say, like most of them are like 6.5 feet tall. Some of them are even upwards of like 7 feet tall, right? This dude is clearly not as tall as an NBA player. So we can say 7 feet is too tall for him. Name a number in feet that is clearly too low for his height. So we know that like the average adult male is, close-ish to 6 feet, probably upper 5 feet. So if I said 3 feet is clearly too low. If we made an estimate of his height, I don't know, I would say, looks maybe like about average, maybe 5 foot 10 inches, let's say. Alright, so now here is a picture of the same man standing next to a child. If the man's actual height is 5 feet 10 inches, which is what I said, what can you say about the height of the child in this picture? So we could kind of make an estimate. It looks like the kid is about like 2/3 of his height. But the one thing that we can say for sure is looking at the two, we can see that the man is definitely taller than the child. So one thing that we can definitely say is that the child's height must be less than 5 feet and 10 inches. Has to be true. We see right here, he is lower than him. So if this guy is 5'10", then we know the kid has to be less. And so let's say we wanted to use the variable c for the child's height. We could write the inequality that c, the child's height, is less than 5'10", which is, we'll just leave it like this for now. Okay, so we wrote an inequality to show that the height of the child, which is what C represents, is less than 5 feet and 10 inches. That's the kind of stuff we're going to be doing today. So, next activity, stories about 9. Here are 4 situations with the appropriate number lines representing them. So the number lines for the situation have been included. Analyze the situation and number line and describe the possible numbers that would work in that given situation, and write an inequality that would represent those numbers. So a fishing boat can hold fewer than 9 people. How many people can it hold? And so we're going to use the capacity for the boat as X. So a description or a list. So fewer than 9 people. So can it include 9 people? No, it has to be less than. So it could hold 1, 2, 3, 4, 5, 6, 7, or 8 people are all the possibilities. And so as an inequality, the boat must have less than 9 people. So any of these would work. If the person wanted to take the boat out, could go solo, could go with 3 friends for a total of 4 people, could bring up to 7 people, as long as it's less than 9. And if we look here at the number line even includes 0, so we could say the boat holds a nobody. So it could be 0, 1, 2, 3, 4, 5, 6, 7, or 8 people. So this is a number line that has 8 different values marked on it, because all 8 of those possibilities make total sense. Okay? So, for the next one, Lynn needs more than 9 ounces of butter to make cookies for her party. How many ounces of butter X would be enough? So once again, we're seeing the word more than 9 ounces of butter. So, what would the description of the possible numbers be? So here you saw that I listed out all these numbers, 0, 1, 2, 3, 4. So, should I do the same thing here? So, I'm actually not going to do the same thing here, and here's why. So, she needs more than 9 ounces. When we're talking about weights of ingredients, it's a little bit different than people. Because can't we have 9.5 ounces or 9 75/100ths of an ounce? Right? Are weights always perfect to the exact ounce? No. People, there's only such thing as, 0 people, 1 people, 2 people. There's no such thing as 35/100ths of a person. So for this list, it was whole numbers less than 9. For this one, it is any value more than 9. That's including decimals or fractions. And that reason is because because there are such thing as decimal or fractions of an ounce. And so you can see on the number line here, each dot represented the person. So there were 8 different possibilities, and there was this blank space in between, because there is no such thing as 0 and 5 tenths of a person. So they had to have individual dots, where here it is just this ongoing line where it's saying it could be 10, it could be 12, it could be 12.5 right here. So that's why this one uses a number line versus dots. So this is dots versus ongoing line, right? Important to see the difference between those two things. So, in this instance, the quantity must be greater than 9. Okay. And before we move on, I want to actually go back to this boat one real quick. So I said that the boat can hold anything less than 9 people. I want to add to that X could also be 0 people, and that X must be greater than 0. The reason is, if I said that X is less than 9, then that means that I'm saying that there could be negative people, which isn't true. So I want to make sure that I'm also including that X is less than 9, but greater than 0. Okay, just wanted to add that. So for number 3, a magician will perform her magic tricks only if there are at least 9 people in the audience. For how many people will she perform her magic tricks? So what does at least mean? So if I said that you must be, like, let's say you went to Cedar Point, right? And you must be at least this tall to ride this ride. What does that mean? So at least means that you are that height or more, right? So the description of this list is the number 9 or any number greater than it. However, we're talking about people again, so once again, it needs to be whole numbers, because there is no such thing as a fraction or a decimal of a person. So once again, on my number line, we can see that here. So here's 9, and then there's a dot for each person thereafter. So, and my inequality then it must be 9 or more people. So oftentimes, when we want to include that number, so here we said x needs to be greater than 9. Was it including 9? No. So here, it's x is greater than 9, or x could also be 9. So we want to include that. There is a way to combine that, which is this, which means greater than or equal to, which there's no way to type that on your keyboard. So this is just kind of another way of showing it. X can be greater than 9, or x could be 9. If we were writing on paper, this is the symbol we'd show that is greater than or equal to. And for the next one, a food scale can measure up to 9 kilograms of weight. What weights can the scale measure? So once again, we're talking about weight, so decimals and fractions can be included. And if we look at our number line, though, it's got 2 dots. It stops at 0. Why? Why aren't there any negatives? Because is there such thing as weighing negative weight? No. So this would be any number including decimals or fractions between 0 and 9. Right? Because we could be talking about the food scale could measure half a kilogram, 2 kilograms, 2.75 kilograms, because weight can be broken down to even smaller than whole numbers. And so that's why we have, once again, instead of the individual dots like we have up here, we have this whole number line. And it's up to 9, so it can measure 9, it can't go any more, so it stops. So x must be greater than 0, because it can't be a negative, and x must be less than 9. So the maximum it can hold, it cannot go above 9, and this is the minimum, because obviously there's no such thing as negative weight.